The small plastic bump resting on your seatbelt isn't a design flourish. It's not a manufacturing error, nor is it intended to strengthen the strap. This unassuming piece serves a highly precise function. It positions the belt so your restraint system can operate exactly as engineered for your body. For those who have ignored it their entire lives, the consequences can be severe. The belt might fail to protect properly during a sudden collision. This isn't exaggeration. The National Highway Traffic Safety Administration has documented injuries and crashes where seatbelts were worn incorrectly, and this tiny clip is designed to correct that fatal misalignment, yet it's only a single element within a far more complex network. Modern vehicles built over the last 20 years include multiple hidden mechanisms within their seatbelt systems that remain invisible to most drivers. If the belt's placement is off, these mechanisms may fail entirely, or worse, amplify injury during a crash. Understanding the role of this plastic piece is essential before examining the entire system. Known as a strap guide or belt positioning clip, it is permanently attached to the webbing at a mathematically calculated point. Its mission is to hold the diagonal belt snugly across the sternum, keeping it away from the throat, particularly important for drivers shorter than the average adult height that the original system was designed around. The three-point seat belt, pioneered by Neil Boland at Volvo in 1959, remains one of the greatest advances in automotive safety. By the year 2009, Volvo estimated this invention had saved over 1 million lives. Before Boland's breakthrough, vehicles relied on lap belts, which often caused catastrophic abdominal injuries and frontal collisions. The diagonal strap distributes crash forces across the pelvis, chest, and shoulder, preventing a single weak point from absorbing the brunt of the impact. However, Boland's original design used the dimensions of the average European male, roughly 5 foot 9 inches tall. This created a structural limitation that took decades for automakers to fully address. For drivers measuring 5 foot 2 inches, the diagonal strap naturally rides too high, pressing against the throat rather than lying across the chest. In this position, it cannot transfer the kinetic energy safely into the collarbone and sternum, and instead directs the force to the trachea and cervical spine. Real-world crash tests from 1987 showed that a large percentage of chest and neck injuries in shorter drivers resulted solely from this poor strap placement, not from any failure of the belt itself. The equipment was functioning as designed. The blueprint had simply not accounted for a wide range of human sizes. The small plastic nodule corrects this anatomical mismatch. By threading the belt through this guide, the strap can be adjusted so it crosses the chest properly, staying clear of the neck. Once secured, the clip maintains this critical alignment throughout the drive. It is not a minor comfort feature. It is a mass-produced solution to an oversight that some manufacturers recognized long before others considered the driver's responsibility in belt placement. Many people have sat in cars for decades with this feature unused, unknowingly compromising their own safety. Proper use of this guide does more than prevent chafing or improve comfort. It is a prerequisite for activating two hidden mechanisms inside the belt retractor, located within the B-pillar where the belt attaches to the vehicle frame. These mechanisms, a pretensioner and a load limiter, work in a precise sequence during a collision, and both rely on the belt resting correctly on the body. Understanding how each functions independently and in tandem reveals the true protective role of the seatbelt. The pretensioner eliminates slack in the first milliseconds after a crash is detected. Sensors monitoring rapid deceleration, the same ones controlling airbag deployment, send an electrical pulse to a tiny explosive within the retractor. The charge detonates, activating a piston or specialized spool that immediately retracts 4 to 6 inches of belt. This occurs before the occupant begins to move forward, ensuring the belt is taut at the moment of impact. With slack removed instantaneously, the belt can restrain the body without delay, maximizing protection and reducing the risk of injury. If a seatbelt is slack, whether due to poor placement or casual fastening, the pretensioner expends its energy taking up the looseness rather than restraining the driver's body. That means precisely when restraint is most critical, the mechanism is still pulling in webbing instead of halting forward motion. Studies published by the IIHS in 2019 reveal that even 2 inches of slack allowed a driver's head to move 3 inches farther forward during a crash compared to a correctly tensioned belt. In a high-speed impact, those 3 inches can be the difference between walking away with minor bruises or striking the airbag at a dangerous off-center angle, a scenario documented to cause serious fractures to the facial and orbital bones in crashes that would otherwise be survivable. The pretensioner also explains a familiar but poorly understood behavior of seat belts. Anyone who has yanked their belt too quickly while fastening it has experienced the temporary lockup before it releases again. This occurs because the internal inertial sensor detects a rapid surge in belt speed and engages the lock. It operates on the same fundamental sensor principle that triggers the explosive pretensioner in a crash, just calibrated for much lower forces and slower events. In everyday driving, it might annoy you when leaning forward to reach the passenger seat, but during a violent collision, This exact principle prevents the belt from unspooling further as your body is propelled forward by immense forces. The everyday nuisance and the emergency tightening are simply two faces of the same mechanism. One minor inconvenience, the other the only barrier, preventing your ribcage from smashing into the steering column. Immediately following the pretensioner, the load limiter activates. Its function is counterintuitive. It deliberately allows the belt to release slightly at the precise moment you might expect maximum tightness. After the pretensioner has cinched the belt taut and halted forward motion, engineers faced a secondary challenge. If the belt remained completely rigid under peak crash forces, the concentrated pressure across the narrow 2-inch strip of webbing could itself cause catastrophic injuries. The immense force focused on the chest can fracture ribs and bruise or tear internal organs if not properly managed. Safety experts refer to this phenomenon as belt-induced injury. This problem became a central focus in the 1970s and 80s as explosive pretensioners became standard, dramatically increasing restraining forces compared to older purely mechanical belts. The load limiter emerged as a brilliant engineering solution to this threat. Entirely mechanical, with no electronics, it often employs a calibrated torsion bar or specialized webbing designed to stretch predictably. Its purpose is to allow the belt to yield slightly, feeding out a controlled amount of extra webbing the moment chest pressure exceeds a specific threshold, typically between 900 and 1,350 pounds of force, depending on the vehicle design and the occupant's weight category. The belt does not release the passenger entirely. Instead, it prolongs the impact duration by a fraction of a second, gradually letting out webbing to reduce crushing force on the ribs and sternum while keeping the occupant securely in place. Data collected by Euro NCAP on European vehicles from 2015 through 2020 demonstrated that pairing a properly tuned pretensioner with a load limiter reduced the risk of severe chest injuries by 23% across simulated crash scenarios compared to older systems that only employed pretensioners. This brings the discussion back to the small plastic clip and its role in enabling these hidden safety features. If a short driver neglects the positioning clip, causing the diagonal belt to ride near the neck, the pretensioner will cinch the webbing across the throat instead of the strong bones of the chest and shoulder. The explosive tightening meant to restrain the torso now impacts delicate structures like the trachea and cervical spine. Consequently, the load limiter releases slack based on pressure applied to areas not designed to handle such forces. While both mechanisms trigger in the correct sequence at the precise force thresholds programmed by engineers, the misaligned belt leads to injuries far more severe than those predicted in simulations. This starkly illustrates why belt placement is critical. It isn't merely a matter of comfort. It is essential for the safe operation of a complex system involving explosive pretensioning, calibrated mechanical deformation, and split-second timing. That tiny plastic clip is the link connecting your unique body dimensions to this intricate safety system. If the anchor is too high, the strap will naturally ride toward the neck, even with the positioning clip engaged. Too low, and the belt may slip off the shoulder during a crash, negating its ability to restrain the torso. The proper sequence is to first adjust the B-pillar anchor until the belt rests correctly across the collarbone, ensuring that the positioning clip can then fine-tune the strap angle for maximum protection. Only after the B-pillar anchor is correctly positioned should you engage the plastic positioning clip to fine-tune the diagonal strap across your chest. Reversing this order creates a frustrating cycle. Adjusting the anchor afterward alters the tension and angle of the clip, forcing you to restart. For most drivers, the factory or previous owner's default anchor setting aligns with an average height, leaving anyone taller or shorter exposed to a systematically flawed geometry on every mile traveled. The fourth crucial element is the lap belt, which is often ignored because it demands conscious placement each time you buckle up. This horizontal strap must sit firmly across your hip bones, specifically the iliac crests, the bony ridges designed by nature to absorb the massive forces of a frontal collision. Never allow it to rest over soft tissue or your stomach. The reason is stark and undeniable. In a crash, a lap belt positioned over the abdomen transfers enormous forces directly to your internal organs, rather than to your skeletal frame. This produces a well-known clinical pattern called seatbelt syndrome. Trauma centers recognize it as a condition where the pancreas, small intestines, and mesentery are crushed, frequently accompanied by lower spine fractures, as the belt acts as a rigid fulcrum over the soft gut. The most common cause of an incorrectly placed lap belt is seat angle. Reclining your seat excessively, often done for comfort on long drives, shifts the belt upward toward your waist. Toyota's technical manuals over the past 15 years specify that the seat back should remain within 25 degrees of vertical to ensure safety systems function as intended. A 45-degree recline can elevate the belt 3 to 5 inches higher than designed, enough to completely bypass the protective hip bones for many occupants. Finally, there is the overall tension of the strap. Even a perfectly positioned belt is ineffective if it is worn loosely. Some drivers find snug belts uncomfortable and pull out extra webbing, which directly undermines the pretensioner. Beyond high-speed collisions, slack compromises performance in moderate impacts, the kind that might not trigger explosive pretensioners, but are still capable of causing whiplash. A simple test can confirm proper fit. Once buckled with the anchor and clip adjusted, you should only be able to slip 2 or 3 fingers between the strap and your chest. If your whole hand fits, the belt is too loose. Pull the diagonal strap toward the buckle until it rests firmly against your torso. This brings up an obvious question. Why didn't the salesperson explain any of this when handing over the keys? There's no conspiracy. It's simply a mix of rushed sales processes and the assumption that seatbelt use is common knowledge. The vehicle has a warning light to indicate the buckle is clicked, but no sensors verify geometry or whether the lap belt is crushing organs. The system assumes that once it hears the click, you have done your job correctly. The data tells a different story. A 2020 NHTSA study analyzing 3 zero or zero serious accidents where occupants were confirmed belted found that nearly a third of injuries were worsened by poor belt positioning, not belt failure, not absence of a belt, just incorrect use. To guarantee the protection you paid for, there's a simple 15-second routine that establishes a baseline setup, or resets it whenever someone else has driven your car. Step 1. Sit naturally in your driving position and ensure the seat back is tilted between 25 and 30 degrees from vertical. If you normally recline heavily, bring it forward for this adjustment. You can decide later whether comfort outweighs safety. Step 2. Adjust the B-pillar anchor height. Slide the lever so the diagonal strap crosses the exact center of your collarbone without grazing your neck. It's easiest to do while unbuckled, then fasten the belt to verify. If the strap touches your throat, lower the anchor. If it teeters off your shoulder, raise it. Step 3. Check the lap belt. It must rest on your hip bones, not the abdomen. Press down to locate the hard iliac crests underneath. If the belt sits on soft tissue, pull it down and hold it in place while tightening the shoulder strap to remove slack. Step 4. If the diagonal strap still rides too close to the neck after the anchor is set, thread the webbing through the plastic positioning clip. Adjust the clip until the strap sits centered between your shoulder and sternum. Step 5. Verify the strap's tension. Only 2 or 3 fingers should fit between the belt and your chest. If your entire hand fits, pull the strap toward the buckle until it is snug. It's essential to understand the limitations of this technology. The 3-point belt is a triumph of engineering for frontal and angled impacts, which account for 57% of road fatalities. In those moments, it is the most effective safety device in the vehicle. During a side impact, the belt acts as an anchor, enabling side airbags to perform effectively. In a rollover, it is your primary defense against ejection, the leading cause of death in such crashes. In rear-end collisions, however, the belt plays a minor role. The headrest and seat structure provide the main protection. The positioning clip is not a substitute for a booster seat. If an occupant is too small to achieve a safe belt line across the collarbone, even with the lowest anchor and clip settings, the adult system simply cannot protect them. That tiny plastic button exists because engineers studied the data and recognized that a large portion of the population is at risk due to a simple geometry mismatch. It works in tandem with explosive pretensioners and calibrated metal to save lives, but only when the user is properly positioned. These 5 steps take 15 seconds, require no tools, and determine whether the safety system functions as intended or fails in a critical moment. I have one final question. Did the person who sold you your last vehicle explain any of these adjustments when handing over the keys? Yes or no? This will reveal how much life-saving information actually reaches drivers. For those interested in a deeper technical exploration of hidden vehicle systems, new analyses are published weekly. Next, we will examine ABS braking and why the correct technique for stopping on snow or gravel is the exact opposite of what drivers are taught on dry pavement. Thanks for watching. See you in the next one.